Hello and welcome to Introduction to Scripting Languages. That was my impression of you with the introduction.
You
there.
really? Do I sound like that? See, I would have said it like this. Hello and welcome to Wibbit.net Introduction to Scripting Languages. That's how I would have done it.
Well, that's you imitating yourself. I got your inflection pretty much spot on there. Hello and welcome to Introduction to Scripting Languages.
And you may have. Well, which one in particular are you talking about?
I think I've listened to the beginning of Introduction to Computer Programming probably over 100 times.
Oh, that one's the worst one because every time we've ever built anything, we've used that as the test. So I've heard that. Hello and welcome to the first video of the Introduction to Computer Programming tutorial series. My name is Kevin, and to my right I have Brian. I've heard that a billion times. I'm kind of sick and tired of that one, man.
Well, there's that one, and then there's also the Java.
Yeah. That's a good one.
Yeah.
Well, ladies and gentlemen, welcome to Wibbit.net Introduction to Scripting Languages. This course, Jason and I will be taking you through just kind of getting used to the whole concept of scripting languages, so that we can then start to get into some scripting languages that I know a lot of you guys are really interested in, stuff like Python and TCL. We've had a lot of requests for those types of languages, and then, Jason, that'll branch off into other great stuff like JavaScript and jQuery, PHP, ASP. This is kind of the launching point for all those different exciting languages.
Yeah, it's a jungle out there, as the slide says. Welcome to the jungle! We got Python and TCL.
So, Jason, let's talk about this real quick. So, what exactly is a scripting language?
A scripting language is a language that can be is interpreted and then executed. That means that it is the full script that you write is read and then acted upon. You have to write it kind of in a sequence. You have to write it from start to finish. It's read kind of like a story or a book. If you were going to read a story or a book, you read it from the beginning to the end, and then you form your opinion on that story or book, and you're probably wrong, but a computer is not wrong, so it interprets your script from beginning to end and then executes the commands that you gave it.
Right, yes. And as we'll learn later, there are various different types of scripting languages and dynamic programming languages. They all kind of function, their own way, but there are a lot of commonalities between them, and that's what this course is going to be kind of attacking. So when we look at the different types of scripting languages, you typically have these are the two major kinds. You're dealing with a batch language, which those of you guys that have ever made a batch file or a shell script, you're very familiar with this. It's a language that just simply executes command line execution. So if you want to write a batch file that just listed all the directory, all the files in a directory that was .tmp, and for each one of those files, it deleted it. Those are just basically executing command line calls. And the script is, as Jason mentioned, was the story of the program. The script provides the framework of the story for the different command line calls to be executed. And as the years have passed, developers had looked at and used batch languages and been like, you know what, this would be great if I could just have some additional features, like maybe object-oriented programming, or maybe I can do subroutines, or blah, 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 blah. So that kind of led to the evolution of the dynamic programming language, and we will be focusing on that more in the Wibbit.net courses. But just so that you guys know, these are the two major ones that you'll see out there in the software development world.
What is the real difference between a scripting language and what we've seen so far? Difference between a scripting language and, say, a compiled application. So with scripting language, what you write is interpreted just as you write it. Like we said, just like a story, it's read. While a compiled application, that's going to take the code that you wrote and package it up in machine code by a compiler, and then it's ready for execution. Then there's, the other type, Java, C#, where your source code is converted to something that a runtime environment can read. So Java comes with its own, storyteller, and we're talking about stories. So let's say Java is translating French to English for you. You can write something in Java, and then Java can translate it to the machine that you're running on.
What is that stupid language that the Star Trek people say? What is it? Klingon.
Klingon? Yeah, Klingon.
Yeah, so when I think of like the JVM, I think about Klingon because I'll sometimes open up those files. I know that you're not supposed to, but the class files up in like Notepad++, and I'll just see and like a word and then a word. So
I've done that so many times now, I don't even see the code. I just see blonde.
I just see a woman in the red dress.
Yeah, every time that's all I see. People are like, why are you staring at that gobbledygook? And I say, why are you saying gobbledygook? This isn't the 1950s.
So here is the compiled execution that we're familiar with and that we've spent a lot of time on with C, C++, Objective-C. We have a source code file that we run against a compiler that will produce native machine code. Now, that means that it's going to run really close to the hardware and give you the fastest type of execution. So when we actually execute this binary file, it will run on that system. So this is one type of execution that you're familiar with. Now here's another type that you're familiar with, and this is the Java C# stuff where we, instead of compiling to native machine code, we compile it to a intermediate code or bytecode that is architecture independent, and then the differences between the different systems, the different system architecture, that is what is different. So you'll have a 64-bit JVM running on this machine, 32-bit JVM on this machine, Macintosh JVM running on this machine, and theoretically the same bytecode should execute on all the machines.
Performance may vary.
Performance will vary, absolutely. And there are many instances in computer science and software engineering where you'll see where that's not true, but for the most part, that's what the theory is all about. So we have the bytecode compiles to intermediate code. Then that bytecode is just-in-time compiled, so that means that it's compiled right before it executes to produce the application. Just to kind of wrap up that discussion there, the scripting language, we're basically going to be interpreting commands and then executing them. Now, again, this will vary as we get into more of the dynamic languages, but you can sort of think of it like this. Like Jason gave a really good example of a story, the script. It's a story, and it tells you what's happening, and then things just happen based on the different elements in the story.
Like Game of Thrones.
Like Game of Thrones.
Game of Thrones, you have a favorite character, and then in the script, you get that character killed every single time. As soon as you fall in love with that character's going to die. That's how the script works. So we've gone over our workflow of our compiled and interpreted languages, and the workflow doesn't seem all that different for a scripting language. You start off with the code that you wrote. It goes through an interpreter, executes into native machine code, and then you have your output. So your workflow is not really that much interrupted. You're still writing your code, and it's still going to run through and execute in the way that you wrote it. But the difference is there's no middle step. The middle step's happening on the fly. It's happening as you're going.
And the source code of your program is what's actually directly being ran. It's not being converted into bytecode. Just so if you want to open up a Perl script, that's the Perl code in there. You pick it up and hey, that's the source code.
We write our code, something happens, and hey, buddy, wow, it's magic, right? Well, with the compilers, we have that step of compiling the code, but just like Kevin said, you open up your Perl script, what's written right there is exactly how it's going to go. The source code is what's being executed. There is no middle step where things are being converted. What you read, you write is what you get. It's like the old WYSIWYG editor idea.
Oh yeah, man,
what you see is what you get. So what you write is what you're going to get on the other side.
So here's kind of a little stupid example of interpreting a script. Just like we had in the last slide, we mentioned that it's sort of like you read a paragraph, you interpret it. You read another paragraph, you interpret it. Let's kind of take this into practice. So I know that this is just a really stupid idea, and you may feel like we're insulting your intelligence, but that's kind of what we do at Wibbit.net. We're smarter than everybody else, and we know it, and we like to prove it. So here's Wibbit the Frog. He's just kind of chilling here. So Wibbit the Frog is a frog. And I know this because my script told me that, so there's my frog. So Wibbit the Frog has 10 cookies, and I know this because my script told me that there are 10 objects, and those objects are cookies.
I don't think you have 10 cookies there. I think you have 9. No, you have 10.
Is it 1, 2,
no,
3,
it's 10.
5, 6, 7, 8, 9? That's 10, you dummy.
That's totally 10. Well, I mean, I always question the man. The man says there's 10 cookies. I wouldn't be a very good scripting interpreter. So I always question the man.
You would be a horrible scripting interpreter. Be like, X equals 1. Why? What? No.
Why? Why does X equal 1? Because it does. Just shut up and say it. No.
It was like that Family Guy episode where Peter.
Yeah, that's what I was going for.
Yeah, Peter was like his great philosopher. You need to get a job. Why? So we got the 10 cookies. Now Wibbit the Frog eats 5 cookies. So he's going to open up his big gulp, and he's going to sculpt those.
That was an amazing animation.
Yeah, it was top
That was
notch.
really good.
So
That was
how
really
many
good.
cookies are left is the question that we're asking at the end of this series of instructions. Again, let's evaluate this. Let's really think about this. We just evaluated a list of instructions one line at a time. So we read each line and we interpret it into something that we understand. So we take this out of a computer context and put this inside of our daily lives. Our brain was able to do all this without us doing much thinking. So the characters in those sentences, they represent different sounds, and our brain is able to take those sounds and make words of them, and then a combination of those words makes a statement. I mean, that seems logical, but this is exactly how a scripting language is executed for the most part. And my brain will examine these statements, and it will make meaning out of them, meaning it will interpret them into something that my brain can understand. So I'm taking something and converting it into brain signals, which is machine code.
Sure. That makes sense to me.
Yep, and we have a sequential list of statements, so that means that each one builds on the other. So we had to define the fact that Wibbit the Frog had 10 cookies before he ate 5 cookies. Otherwise, we're going to eat 5 cookies that don't exist, and then that would cause a problem, because that's bad.
So, Kevin, by your analogy, we wrote something in the English language. So to say Wibbit
Or
is
the American language.
the American language, I'm sorry. we wrote, while eating our freedom fries, we wrote down that Wibbit the Frog is a frog. We wrote that in English. Our brain is able to say the word, able to understand the words on the page that say Wibbit the Frog is a frog, and we're able to associate that with an idea of a frog.
Mm-hmm.
In our brain, based on what's written on the page. The word frog isn't a frog. We know what a frog is.
Right, it's been
and we now know
predefined.
Wibbit the Frog is a frog based on the statement, and our brain is able to interpret that.
Mhm.
Once that interpretation has happened, we have an epiphany moment where we say, Wibbit the Frog is a frog, because now we've taken the words on the page and converted them to kind of a tangible thought. We're able to associate the things together.
Let's look at this other stupid example. So in this example, we have the monkey and the frog. And Jason, the monkey speaks monkey language and the frog speaks frog language. Now, if they want to speak to each other, he's going to say, ooh, ooh, ah, ah. And the frog is going to have no idea what that means. Now, why is that?
Well, because the monkey speaks monkey language, which is mostly throwing its own feces, and the frog speaks frog language.
So the two can't communicate with each other, so I guess we can just call it a day and say, this, we're out of here.
Okay, well, I'm going to go drinking then.
All right, man, see you later. Oh, wait a second.
Oh, you got me.
We have something introduced here, Jason, to help us out. What's going to happen now?
Well, it's the bobblefish of the animal kingdom, the ever-present fly, who's going to interpret the monkey, because clearly flies know every animal language.
Yes, they do. Well, they spend a lot of time. They buzz around the feces that the monkeys throw around, so he's picked up a lot.
That's how monkeys communicate, by throwing feces, and flies are like flies to shit. So they understand the monkey language, but frogs eat flies, so they can absorb the fly's knowledge. I don't know if that analogy is actually going to work, but we're going to go with it. Oh, that's not nice. The monkey called the frog stupid, and the fly. The monkey thought the frog wouldn't understand, so he's like, "Oh, you're a stupid frog," and then the fly's like, "No, buddy. Hey, he just called you stupid." So the fly is actually an instigator here.
What are you going to do about it, Wibbit? Huh? What are you going to do about it? Go get him.
I heard he said you were stupid. I don't know. Not my words, but interpreters always causing problems.
So, Jason, let's talk about the different types of scripting languages. Now, we've basically gone over a lot of this stuff already, and we're going to keep drawing this into your heads. Let's now talk about what is a script. Now, let's get into it, Jason. Let's go.
A script is a non-compiled program. It extends the capabilities of another program.
Wow. Now, that is a very, very succinct definition of a script.
That sums it up right there.
That's it. That's all it does. That's all a script is.
So the script is not compiled. It's not turned into a bunch of gobbledygook or machine code. It is actually legible source code. You can actually open up a script at any point in time, anytime you want, and actually read the logic that goes behind it. The extending program, the thing that is reading that source code, that is compiled. And that interprets your script, but your script, the thing that you're writing to actually do something, that itself is not compiled and is, fully readable and modifiable.
Yeah, so I guess this kind of sums it up and sets the stage that a script is intended to just be an extension of another program. And I will get into some of that stuff in a little bit, But just to kind of give you a bit of a taste, if you think about like the Python interpreter, the Python script is actually pushing its will on the interpreter. The interpreter is what's actually being extended by the script. So that's kind of important to understand what that is and how that works. So types of scripts. So there isn't only one type of scripting language. So each type is uniquely identified by how it's used. And there are a lot of different kinds, but here are a few common ones.
So we got a tool chest. You got to pick the right tool for the job.
Yes, sir.
So if you've ever had a situation where you wanted to do a bunch of things on a computer and you wanted to do them kind of in a specific order, like log into an FTP server, download a file, then log into another FTP server, upload that file, and then play a MIDI file of Celine Dion over your speakers when you're completed, you would write a job control automation. You'd write a script to do that. You would in your script, you would say, log into FTP server, download file, log out, log into the second one, upload, log out. Play Celine Dion, My Heart Will Go On.
That's the thing right there, man. That's what makes it all worth it.
The right tools for the job. And the right tool for that job is Celine Dion. MIDI files.
So when we talk about extending, Jason, we were saying that a scripting language extends a different program. A job control automation is extending the native command line shell. And it's just all that it's doing is telling the command line shell what it wants to execute. There's also a sect of scripting languages called screen capturing. It's also often used as GUI automation. And really what that does is automating a process by defining specific user interactions with the machine. And GUI automation extends the user interface of the operating system by telling it what to type, what to click on, what to do. Sometimes
like where to move your mouse to.
Exactly.
Where to do that kind of thing.
You'll see stuff, and I mean, I've actually seen in different industries where they have these old systems, like these old mainframes, and they have these like really crazy ass, setups where they have to like do a million tasks in a nightly batch job, and you'll be sitting in front of a computer, and the task will fire up, and you'll see like windows flying all over the place, things typing in, like it's kind of fun to watch. But a lot of times when you see this type of automation, it's when very, very old technology is still being used as core business infrastructure, and they just basically need to use something that's not designed to have automated process automatically.
I want to throw out a theory.
Okay.
The cards jumping at the end of Solitaire was inspired by watching that kind of screen scraping.
It may have been. Bill Gates was probably like, yes, make the cards fly in my face.
He watched one of these batch jobs going, and he's like, this is a soothing thing to watch. I want this to be a reward for playing a game by myself and having no friends.
Jason, I don't even see the cards. I see a woman in a red dress.
Woman in a red dress, Suicide Kings. I agree. So we've all visited web pages. We've all had to make a big presentation in Microsoft Word at one point or another.
We did?
The way that those elements on the page
are we using PowerPoint right now?
I mean, we might be. Would we get paid if we said we use PowerPoint with Microsoft? That's like an endorsement, I think,
right?
We'd
probably get sued for something, I'm sure.
Yeah, I don't think Microsoft wants to be associated with us. So we're using the open source equivalent of what would be called PowerPoint, and something had to come together to put this stuff on the page.
Yep.
It had somebody had to like arrange it, just like we're telling a story. You also build a house through a set of blueprints. So if you're going to a web page, there's a script there that acts as the blueprints to put the page together for you, and the instructions are read and the page is put together and then displayed for you in the way that it was designed. Oh, I just thought of a joke. I don't want to make the joke. I want to make a joke about have you ever hung out with an out of work contractor or builder? They're never fun. They're always complaining that they have nothing to do. I don't know if that's a good joke to make.
I don't even know if that makes sense. How does that make sense?
Well, because if you have a web browser opened up with no web page, what are you doing? You're just staring at it. It's not doing anything.
It's just a white document.
It's just blank.
It's nothing.
It's very boring.
Yeah.
It needs those blueprints to make something happen. It needs something to come along so it can build it, so it can show it to you. But otherwise, it's just sitting there. And I mean, I know maybe I'm alone here. I like looking at the Chrome icon, so I'll just open up Chrome and stare at the icon.
You would do that.
And marvel in the beauty of the icon. But even the act of showing me the Chrome icon, there was a script somewhere to do that.
It might be, but I know where you're getting at. So we're extending the application that we're extending with document formatting is the presentation application. So something like you start to think about when the PowerPoint presentation we're looking at right now, that's using OpenXML, which is what the DOCX or PPTX file extension represents. It's a XML document format, and that is what interprets in PowerPoint will interpret that and display it. You go to a web page, the same kind of thing. We get HTML, whatever, and that's used to display it. We also have the general purpose programming languages. Now, this is the meat. This is the good stuff right here. It's a scripting language that mimics the behavior of a full-scale programming language. Now, these are not compiled. I mean, technically, you can compile Perl, TCL, or Python to executable, but traditional way to run it would be to run it against the interpreter. And it extends the capabilities of the underlying interpreter, which we said just a little bit ago. So the interpreter is actually what is asserting itself on the machine, and the script is simply telling the interpreter what to do.
Now, a studious student may point out
a studious,
at some point.
And a studious student.
Yeah, I said it.
Isn't that kind of like a double thing?
It's a thing. It's funny. We had Java, where you have a language that you're writing that's then compiled by an interpreter, so it can run platform agnostic.
Mm-hmm.
But now we're talking about the interpreter in this situation. So, what are the key differences there? What's the difference between Java running a platform agnostic and Python running platform agnostic?
Because when you open up a .class file, it's bytecode. It's not the source code. When you open up a general purpose script like Python, that's the source code, and the interpreter will just take the source code and run the instructions. Whereas in the case of Java or .NET, it takes a compiled bytecode, which is if relatively efficient, and then it runs that against the runtime environment.
I see. Well said.
So we have some controversy, dude. What is this all about?
I don't know, but I've gone on a lot of forums, and there's some bad blood, and people are calling out Perl and Python. They're saying that they shouldn't be called general purpose scripting languages, but then there's people in the Perl and Python camp that are like, yeah, we're general purpose scripting languages.
What? What you can do about it?
There's nothing sadder than watching pasty, malnourished, basement-dwelling software engineers arguing about whether or not a language is one thing or another. There's nothing sadder in this world. But here we are. So we've got drama. We've got some major drama. And by major drama, I mean it's as much drama as any two people can muster when they live in their parents' basement and they don't see the sun all day. So not a lot of drama, really. But so we have Perl and Python, general purpose scripting languages, dynamic programming languages. Which is correct?
I don't know.
Both are correct. Why not both? Historically, scripts were used to extend existing applications, and as time has progressed, scripting languages began being used to write programs from scratch as the primary language.
Wow.
So because of that, it is technically correct to call these languages dynamic programming languages, but they were already called general purpose scripting languages, so both are true.
Right. So I guess the distinction is as the languages evolved, and you didn't just use Perl to delete files from a directory anymore. You actually used Perl to write a program from scratch.
To do something.
Yes, so that's sort of where the break-off is.
Now, one could argue that you were doing something by deleting a file in the first place, but that's just conjecture. We're just getting...
Right, yeah. You start adding things like object-oriented programming and those types of things, which are typically, your hardcore computer science concepts. That's really where the change in the split happened.
Well, as time passes, many of these scripting languages are including advanced programming structures. This line will just keep getting more and more blurry.
Dynamic programming languages. So Jason just alluded to DP languages a minute ago, so let's kind of more accurately define what a dynamic programming language has as its characteristics. They have the ability to create subroutines and functions, which is not something you would typically think on a command line interpreter, could do that. It has object-oriented programming. It uses advanced software development tactics like reflection. You can include external source code files, variable typing. Most of the time, they're loosely typed as opposed to actually specifying data types, but when you have object-oriented programming and you're creating object instances of a specific class or a specific object type, you will type that object. So you can actually say, instead of a number or a string, I can have a complex data type. And it will, and most of the time, they'll use dynamic typing. So when we've used dynamic typing in languages like C# where we use var to figure out what the data types are during runtime, and that's an advanced programming technique. So as the scripting languages absorb more and more of these modern techniques, you start getting into this terminology of dynamic programming languages.
So all this has to come at a cost.
It does.
You don't get anything for free in this world.
No.
So if you're gonna do all this kind of on the fly interpretation of your code, you don't want to have to compile and all that stuff. Expect the code execution to significantly slow down compared to compiled code.
Absolutely.
That's just the way of things. You run a lot, you're going to be more tired.
Yep. Or if you run a lot and you have, weights on your ankles, you're going to get tired faster.
If you eat a lot of cheeseburgers, you're going to get tired too.
That's true.
Because, they sit in your belly and they're delicious, but man.
So let me ask you a question, Jason. If languages like Perl and Python can do similar things as C and C++, then how do I know what language I should be using?
I'll tell you what I usually do. I usually go outside and I get some leaves.
Okay.
And I get a bucket and I light the leaves on fire and I throw them in the bucket. And depending on the color of the flame, I choose a programming language.
Gotcha.
It's tried and true.
Works every time?
I write most of my web pages in C++.
Wow.
They don't actually work, but I write them that way anyway. I've got some amazing websites that don't actually do anything because of that. Maybe I should change my method of choosing something. What's a better way?
I don't know. Well, you tell me. I'm asking you the question.
Okay. Well, C and C++ executes very quickly and can often take longer to produce suitable code.
Right.
So it'll run fast, but it'll take longer to develop the source code. So if you have something that needs to be executed very quickly, like say an ATM machine to calculate available balances or
graphics processing. Like a rendering engine.
Well. Very good example.
Yeah.
Something that has to be done with incredible speed.
Mm-hmm.
Maybe you should use C, C++, a compiled language. That's where if speed of execution is prioritized over how fast you can write the code. Perl and Python execute a bit slower, but it's a lot easy. It's truly a lot easier and quicker to develop in a scripting language like that. You can test a lot quicker. Everything you're writing and you can just run it immediately and see what it does. It's a much quicker development cycle there. And the code can be portable. It can be on any kind of system with hardly any changes to the script itself. The interpreter,
if any, for the most part. I mean,
yeah, your interpreter is what matters there. So is that you don't have to worry about that. You can instantly port your code from one place to another, and if that type of speed is important over execution speed, then you should definitely consider Perl and Python or any kind of scripting language.
So that does that one.
Rock and roll.
I think the frog looks constipated. Ladies and gentlemen, welcome to the Introduction to Scripting Languages from Wibbit.net. Oh, you know what? I can't even imitate myself. Hello and welcome to our 13th video of the Introduction to Scripting Languages tutorial series.
13th.
I don't know what the hell it's going to edit out to be. Doesn't matter. So in this one, guys, Jason and I are going to talk about different implementations of scripting languages and just kind of keep drilling this into your mind, how this stuff works, and really just getting away from the abstract and now actually starting to get our feet into the idea of what scripting languages are used for. And even seeing some very basic, simple scripts. So these common implementations. We've gone over this stuff, but let's go over it again because there are some new concepts here. Batch automation. Yes. So Jason talked about that a little bit ago. So it's when script code will run on the command line and executes tasks in a specific order. The most common examples of that are a shell script or a batch script. We also often will see client-side scripting, and you'll see this very frequently in things like web pages. So the script will download from the server HTML to format the document and JavaScript to drive the events and the user interactions. Server-side scripting executes on a server, and oftentimes it's used to generate dynamic content. Often will be available for services to grab information from a web server, like a web service or something like that. And
dynamic content. Interesting. It's almost like that client-side, server-side stuff might have something to do with each other.
They may work in tandem at some point. I'm not sure, though. We'll see.
Interesting.
We'll see. But you'll often see stuff like PHP, CGI, Java has a lot of server-side stuff like Java Beans and all that fun, happy stuff to generate server-side content, and maintenance. And maintenance basically takes advantage of an advanced programming language to build logic to execute maintenance tasks. Now, a lot of maintenance tasks are executed as batch automation, but let's just say that you needed to have some more advanced features like recursion or something like that. It would be nice to be able to have a simple script that I can write with a simple language and execute that as interpreted, and we'll see an example of that in just a little bit.
So every morning at 6 a.m., there's a list of files delivered to your server. And you wake up at 6:30 with your coffee made you're ready to go, and you want to copy each file from your server to your customer server.
Well, this is what you do. So you currently do this.
Every morning. I wake up at 6:30, I'm copying these files, and then I go back to bed because I don't actually have to wake up until the crack of noon otherwise. So I really don't want to do that. I want to automate this job. I want the machine to do it for me.
Okay, so that way you don't have to get up at 6:30 every day.
Right, and I also am really keen on coming up with ways to lose my job. And the best way to do that is to come up with a machine that can do your job for you. I'm tired of it. I'm fed up. So let's automate this process. So the first thing we have to do is we have to copy what has come to us up onto the server and then delete the local copy. So just like we said before, where Wibbit the Frog is a frog, he has 10 cookies, he eats 5 cookies. Mm-hmm. We have files, we move files, we delete files, one after the other. Mm-hmm. We said this happens, then this happens, then this happens, and the end result is our process is complete and I can sleep into the crack of noon, wake up and wonder, what t-shirt am I going to wear today? Because I am a modern professional.
The one with the mustard stain, preferably.
They all have a mustard stain.
So Jason, now let's sweeten the pot a little bit. Let's add another problem to our automation here.
Uh-oh. So the vendor has increased the cost of delivering the files beyond your acceptable price range. And you need to get the files from the source system at 6:30. I don't know if we still have to deliver them at 6:30, but I'm assuming we do. We could still automate this with an FTP script.
Right. So basically, the vendor said, instead of $1,000 a month, it'll be $20,000 a month for us to send you these files. And you basically say, F that, I'm going to go get the files myself because I'm not going to pay that kind of money.
That is a lot of money. So the first thing you want to do is you got to connect to the thing to download your files. Instead of having them just be on your computer at 6 a.m. when you wake up, you have to add the extra step of getting up there and downloading them in the first place. Well, we already had most of the script written in the copy and upload and then delete. So we just have to add the layer on top to say connect in the first place. Well, how do we connect? We write a second script that step by step goes through how to connect to something. It says open this FTP server. Here are the user credentials. Copy this stuff down into this local folder and disconnect and goodbye.
Mm-hmm. Awesome.
So what should we know about batch automation? There's little to no logic applied in batch scripts. You're not going to do a lot of if this then that kind of thing. It's more step-by-step directions from beginning to end. Application-specific commands are your focus. You're telling your computer, what you want it to do with what application. So you're not trying to calculate things necessarily. You're asking other applications to do that kind of thing for you. The absence of process flow programming structures give batch scripts their status. And as we talked about before, the line between batch scripts and other scripting languages has gotten really blurry. So, I said this just a second ago. Here, I'm going to talk about it both sides of my mouth. We talked about, you're not going to have a lot of like if this then that. There's a lot of you just want to write everything in order. Well, we're getting smarter than that. So we want to say if it's a Tuesday, then upload to this folder. If it's a Wednesday, then upload to that folder. That kind of thing can happen now. Mm-hmm. And we're blurring these lines. We're making it more complicated to make it easier.
Well said. So let's talk about another common implementation of scripting languages, that is the client-side script. So here's an example. You have a server application that provides markup text for client software. So let's just say this client software is like a web browser, something simple. Your client uses an application that parses and interprets the markup text to display it and format it. So that kind of sounds exactly like a web browser, right? So here we go. On the left side, we have our Kubuntu machine there using Chrome. And this is a process running on our machine. Now, this web browser is going to connect to a remote hosted web server that contains a script. When we hit this server, there's going to be logic on the listener that will pick up the scripts and deliver it back. Poo, poo, poo. So even though that's not like a real markup, you can see that there's like a simple, make this on the left, make this in the center, make this on the right. So the consuming application that's interpreting this, even though that's not real HTML, it's sort of a pseudo HTML.
Yeah, it's like a pseudocode.
Yeah, you get the idea that the script said this, my interpreting application showed it like this.
It said, put this here, put that there, put that there.
So what should you know from this example? Even though the code came from a server, at least in this example it did, the client machine executed the markup text. The code was interpreted into a document format by the web client and presented to the user.
So the server holds the blueprint. The browser itself is actually what's going to build it for you.
And the server not only holds the blueprint, but it can generate the blueprint on demand given a dynamic circumstance. So you go to a bank website, it'll load up your banking information because you're logged in. And you go to the same website, or I go to the same website and I'm logged in. I get different content, but
it's almost like it knows who you are.
It does. Now that's actually, Jason, that's what you're going to talk about now, server-side scripting.
Interesting. That's a great transition there.
That happened by mistake, you know.
I mean, I wish the PowerPoint had like a nice crossfade because that would have brought it all together. Like a nice little smooth dissolve. Anyway, so
actually,
an example.
no. You know, I would rather see like the from Wayne's World. You know, I would rather see that.
Okay, go back to the last slide. Let's do it. So go back to the last slide.
You do
it. No, what's okay, we just batched that up. So
yeah, whatever.
The
thought was more fun than actually doing it.
I mean, unless we're gonna headbang to Bohemian Rhapsody later, I don't even want to talk about
that. That sounds like a grand idea.
Okay, after we're done, we'll do that.
Let's do it.
Okay.
Done deal.
So server-side script. You have a web server that accepts an argument from a web client. You want to parse these dynamic variables on your server and serve up content based on these values. So you want to give the web server something in the first place to tell it who you are, and then give you a custom experience based on that request as opposed to what you would just get from everybody. So here we've got our Kubuntu environment, which I didn't know anybody even still used KDE anymore. I thought they just had the Ubuntu Unity 1.
I still love KDE.
I've got no problems with KDE at all. You don't see it. You don't see it very often anymore these days.
I used to use KDE all the time, and when I was in college and I was a Linux exclusive Linux user, I had my
You must have been a whiz with the ladies.
You know, actually, I wasn't that bad considering I was a big nerd. I'll give myself some credit there. But most of the time I'd be like, "Hey, baby, check out my Kubuntu." Then I would get slapped in the face because they didn't know that I was talking about my computer.
That's a common mistake. And well, to be fair, most of the time you weren't talking about your. So
that's true.
Let's be fair. So here we have our nice Kubuntu Chrome environment. You notice something a little interesting in the URL. We're actually going to say we're going to give our request some parameters. We're going to say this variable is something. So here we see write this equals hey buddy. So we're sending that request along to the server. Now we're asking a script, PHP, a question. We're asking this script, can we have something based on this variable? Write this, hey buddy. The interpreter then goes through the script.php, runs line by line. It says, if write this equals hey buddy, do something. What is that something? It writes, hey buddy, sends it back to the browser, and bam, there you have your custom experience of hey buddy. Now, if it said hello world, your browser would have blown up.
Probably.
Which was based on the conditional action in the script. It said, if hey buddy, write hey buddy. If hello world, you're on the wrong website.
That's
we
right.
We don't do that here.
No. Hello World is it's lived past it's lived past its prime.
Those are those other guys. We don't talk about Hello World here. So what should you know? The more you know. There you go. G.I. Joe.
Oh no.
The server received a request from a client. It encapsulated the client's request in its arguments, as we saw with the query string there. The server executed an interpreter against the request script and passed the user's arguments. So based on what the user passed, the script knew what it had to provide back as an answer. This generated the markup response of hey buddy. That response is on the client-side script that is interpreted by the client application. In other words, your request gave a different blueprint for the browser to construct.
Yep, and every time that you send a new value, you'll get a new result. So that's often what client server-side scripting is used for.
As long as that request had a condition matched to it, you'll get a result. Well, if there's exception handling or whatever. But
let's talk about some simple maintenance scripts. Now here's a use case. Let's talk about some simple maintenance scripts. Now here's a use case. You have a server application that writes temporary files while processing. Not that uncommon.
Happens all the time.
Due to some poor core code, meaning this is code that you don't have access to, you can't change it, and the vendor will not change it, or if they will, they'll charge you a ton of money to change it. So this is some poor code, and the application occasionally leaves behind temporary files. So over time, these will consume disk space, and maybe, every 3 or 4 months, you have a major incident on a server where it runs out of space, and it's because there's these old temp files that are there because the application that you're running on that server just sucks and it doesn't clean up after itself. So your boss asked you, I need you to write a program that will recognize these temp files and remove ones that are at least 24 hours old. Right? So there's additional logic there, right? There's a time frame that you have to look for. And so you can see that immediately this is becoming less simple. The files will reside in a directory, and let's just say this is a Windows server, and it's sitting in C:\apps\working. So that's where the temp files will be. We know that just because we know this application. The temp files...
We've seen the problem already, so we know where the problem resides.
The file names will start with the little squirrely there, little tilde there, and they will have a file extension of .tmp, and the first 6 characters inside the file is tmp177. Now, Jason, you see, this is not a simple list file, delete file. We actually have to...
We got to drill down.
We got to find a file that meets a specific criteria, that is at least 24 hours old, and that has the first 6 characters matching that sequence.
We don't want to delete our anime videos by mistake.
That's true. So here's a little flow chart, and just to kind of demonstrate this logic. Now, we're not going to really go through this, but you can see that we have stuff like recursion, we have loops, and we have subroutines. So when we start the program, we're setting it, scan this folder, we are recursively looking for files. If the file exists, we check to see if it meets that pattern, which is the tilde temp. So if it is less than 24 hours old, then exit. Otherwise, read the first 6 characters, and if the first 6 characters equal tmp177, see if it doesn't equal, we'll exit. If it does equal, we'll delete. So you can see, this is a more complicated process. So oftentimes you won't see a batch script or a shell script to do something like this. You would typically see something like Python or Perl, TCL, or any of the other commonly used dynamic programming languages. Let's just kind of finish it up and just formally state these are the things to really notice from that example. We had more advanced programming features like subroutines, recursion because we were doing a recursive directory scan. We had process control like loops, decision statements. So because of this, we will often need to have a more advanced programming language. So, question. Can't you do the same thing with the batch language, just like we were talking about before? Technically, yes, but don't. Technically, yes, but please, please don't. You could eat soup with a fork, but why? You're just being if you do that.
Well, chicken and dumplings is kind of a soup. You can eat that with a fork.
But it's not, okay, but it's kind of a soup. It's not tomato soup. You eat tomato soup with a fork, all right? Now, you know that there's some hardcore, like dork, like smart ass out there that would be like, I can do that. Like you, but...
Yeah, well, I use a spork, so...
See, now that's cheating. That's what a dynamic programming language is. It gives you both. Gives you both of everything.
Perl is the spork of the programming universe. Ladies and gentlemen, Wibbit.net presents Introduction to Scripting Languages.
Nice.
Based on NT technology.
Yes! There you go. Based on new technology.
That's the best intro screen to a Windows ever.
That was the first time I saw that was when I was installing Windows 2000 for the first time. I was installing it on my dad's computer, and I remember just looking at it. It says built on NT technology. I was like, NT stands for new technology. Why would they say new technology? That makes no sense.
Well, it's the same reason why people say ATM machines. All color machines.
I don't say ATM machines, but I've heard that quite a bit.
Yeah, it happens all the time.
Oh man, people. People, listen to what you're saying out there.
Know your acronyms. It's like in the future, people are going to be going LOLL, laughing out loud, loudly.
Laugh out loudly.
Lolling loudly.
Lolling loudly.
Lolling loudly to sleep. Lolling loudly, loftily to sleep.
There you go.
I'm trying to. Anyway, tongue twisters. What are our common languages? We've got Perl, we've got Python, we've got TCL. Give me some PHP, some HTML, and JavaScript, and I'll give you a rounded out common languages portfolio.
Yeah, I mean, I'll tell you, man, when if you all these languages on your resume, including the languages that you've done, C, C++, Objective-C, C#, I mean, that is...
People will be banging down your door literally to give you $100 million a year.
A second. $100 trillion a second. Actually, that's not true. You'll never make that kind of money. So let's talk about Perl. Perl is a high-level general-purpose scripting language. It was originally developed to expand the power of Unix scripting back in the good old 1980s. Back when, what was that movie with, oh Jesus, I can't think of it.
I mean, there's a lot of movies in the 80s, Kevin.
The only winning move is not to play.
War Games.
War Games.
Yes.
So back when War Games was brand new, that's when like people were just getting this whole Perl thing figured out. So the Perl interpreter was written using C, and C is basically the fundamental layer. So almost all Perl objects are reduced to C structs. So that's kind of interesting to know that.
How about that? Isn't that interesting?
So language syntax is purposefully different from C and C++, but it shares a lot of common characteristics. Your C and C++ skills that you have developed with Wibbit.net will definitely port to a language like Perl, because even though it looks different, it's the same almost.
Yeah, it's the logic is similar. The logic's always similar. All these things, you'll be able to port your knowledge to any of them, I would say. Maybe not as easy as this, but still.
So let's keep tiptoeing down the Perl line here. So it follows the theory of no built-in limits. And what that means is the language should be able to be moldable enough to accomplish any task that you can possibly imagine. So that was kind of the creed of Perl during its evolution. Top-down execution with no rigid affiliation to common programming paradigms. So we have elements of object-oriented programming. We have things like multi-threading. So it's a pretty full programming language. The source code is also portable for the most part because interpreters will exist from most of the common operating systems. Now, you do have to kind of be careful. If you want your code to be the most portable, then you don't want to do things like operating system or platform-specific type of things. So here's an example of one, right? So in Unix, they use / characters to designate directory paths. In Windows, they use \. Well, in most of these languages, if you're using Windows, you can still use /, but some people will have \ in their code. So if you run it over on the Linux side, it doesn't work.
It won't work, yeah.
Right. So that's what I mean by, platform-specific code. If you're smart enough to avoid that pitfall, then your code should be pretty damn portable.
Well, and not even, / to /, but if you're writing a script to run on a particular machine that's assuming some sort of dependency, like assuming you're going to extend, like FFmpeg, for example, to transcode a video from one format to another,
right?
And FFmpeg doesn't exist on the other machine you're trying to port your script over to,
right?
Well, it's going to break.
Right, but that's not an issue of platform-specific development. That's a dependency issue, a different topic. But I know what you're saying.
All right, I was just trying to tie it together with another example of something to watch out for. I mean, there's differences in between like Debian and other forms of Linux where you could call something like, I don't know, for whatever reason you wanted it to run apt-get update. Well, it'd be yum update on
right. There you go.
Else.
Now that's another.
But those are also application dependencies. Like yum and aptitude are both applications technically in those different operating systems.
So oftentimes Perl is very commonly seen in web development, and you'll hear the 3 Ps of development of web development, and Perl is one of them. PPP, Perl, PHP, and Python. They're a lot of times they work with each other on web servers to not only generate dynamic web content, but also maintenance the server itself. Maybe you have a Perl script that runs once every day to batch your payments for your customers, or every 6 hours you check to see who hasn't logged in, and you send them an email or just kind of whatever. You'll see a lot of that stuff running in cron, Perl, PHP, Python. They work together pretty well. And it's most common in CGI scripting for web development. CGI is Common Gateway Interface, and it's a standardized method of delegating web content generation to external programs. So we may be doing some discussions about CGI when we get into web development, but CGI was very popular many years ago, but it's still being used today in server-side web development, and almost always CGI is Perl. But you'll see some hardcore developers do CGI in C and C++ because it runs faster, but I gotta say, man, I've only seen that maybe 2 times in my career. Most of the time, it's always Perl. So, boy, this is a long one. Perl is often referred to as a glue language because it is used in integration-type software. And integration software is software that will integrate one system with another system, so it kind of glues 2 systems together. It's also very common in system administration, like I was saying in the other slide, used to execute routine tasks to just kind of maintenance the server and make sure that everything's running cleanly. So what does Perl look like? Here's a simple Perl script. So the pound key is used as a comment, and the variables are preceded with a $sign. So we have a variable called website, wibbit.net. Then we have another variable called write this, and you can see that we're doing variable substitution. Website is the greatest, and then we're doing a concatenation, website in the world. So that actually will interpret to be Wibbit.net is the greatest website in the world. Now you're a Perl master.
Not just a Perl master. We talked about the syntax may not look the same between C and Perl, or C++ and Perl, but this syntax looks awfully familiar to some other scripting syntax.
Yes. And also, the reason why we started from C was so that when you got to this stuff and beyond, it's like, it's nothing. You just look at it like, oh yeah, I know this. All right, Jason, you get to talk about the good one. Let's talk about some Python, baby.
Python. I am deadly afraid of snakes, and this is the unfortunately named application. But I'll talk about it anyway. So at a high level, it's a high-level general-purpose scripting language created to humanize or make it human-readable, something easily understood by humans. Back in the early 1990s, in the days of plaid shirts and puffy parachute pants.
Yeah, and Friends, and that was the worst show ever.
I think we just lost like 60% of our viewing audience when you said that.
I think our viewers will agree with me that Friends is a terrible show, but whatever. What do I know?
agree with you, but 60% of America will defend that show with their life.
Well, 60% of the time it works every time. So
that's right. Python works as a command line interpreter, but it doesn't necessarily require script source code file. Compilers can convert Python code to either native machine code or bytecode that can be interpreted by a VM, just like the JVM, for example. Language syntax is intended to be simpler. However, the statement is very subjective. Some programmers aren't fond of the syntax at all.
Like me, I kind of hate it, but it's fine.
It is intended to be friendly for newer developers, so it's easier to kind of pick up and run with. White space indentation is used to represent code blocks instead of the more common curly bracket. Python has a lot of the same benefits as Perl does. The code is portable, the top-down execution with object-oriented programming entities, automatic memory management, that kind of thing. It's used in almost the exact same way as Perl for web, system administration, and integration of software. And here we are. Check it out. Python.
Wow, it's scary looking.
Yeah, it's pretty intimidating. I mean, we went over Python or went over Perl a second ago. If you ask me, a lot of these scripting languages look they look a lot alike.
They do.
You take a few things out of Perl and you got Python. Okay, so we don't have the $sign to declare a variable, and we don't have our semicolon to end the line, but otherwise it's still the same principle there. We start off this application, import a package sys. We're going to declare a couple of variables. Our first name is Bill, our last name is Mill. Never met anybody with the last name Mill.
Bill, you may not know this, but Bill Mill is one of the example characters that we keep running since the C course.
Oh, I know we reference him, but I'm still saying I've never met a Mill.
No, I don't think anybody's named Mill or Bill Mill. I don't know. I've met Mills. Like I knew a girl with the last name of Mills, but never Mill.
Yeah,
not singular.
No, not just Mill.
Yeah.
Not singular case. It's always Mills.
Yeah, but Bill Mill rhymes, and Bill Mill is a happy-go-lucky kind of guy.
Well, good. I'm happy for him because he's got an interesting last name. So we're gonna say if the first name is Bill and the last name is Mill, then we're going to write out you're friends with, and then we're going to print out Bill Mill. Just drink it all in. There's a look at Python for you.
Yeah, let's drink some Python. Let's talk about TCL. Let's talk about TCL, one of my personal favorites, the Tool Command Language. TCL is a general-purpose scripting language, and it was originally developed to be used as an embedded language back in the 1980s. So once again, we're seeing this theme of like the 80s, you know, because the 80s, a lot of cool stuff came out of the 80s, even though it was corny and some of the music was pretty terrible. And guys, well, just whatever, I'm not going to get into that, but there was a lot of great stuff going on at that time in computer science. Operations are commands. So TCL is actually a command-driven language. All data types can be reduced to strings, or I guess more technically accurate, they can be reduced to binary blobs. It does not natively support object-oriented structures, but TCL extensions can add it, and it can support it. And we have a TCL course coming up. We'll show all that fun stuff. A bracket syntax is used to evaluate commands, and those of you guys that follow the Objective-C course will sort of understand what that looks like, and we'll see an example of TCL here in just a sec. But just to kind of finish this off, TCL is very cross-platform compatible, and interpreters exist for the most commonly used platforms. APIs exist for languages for C++ and Java, and it's very easy to interop with TCL code. So a lot of times you'll see TCL used as an extension of a program. So you have an application that runs, oftentimes it has a Java base or C++ base, and you need to have some piece of customization in that software. The TCL script will be used for that, and it's often used in a lot of different industries, and I think we'll talk about that in a second. But you'll see it use embedded software extensions, so it integrates seamlessly with C++ and Java applications, and it can provide some customization to that software. Very commonly used in integration software, so some powerful and widespread integration engine software makes use of TCL's fast performance. And this is very common in a number of industries. You also will see it a lot in expect scripts. Now, I know some of you guys maybe have seen an expect script or had one break on you, because they do break a lot, but an expect script is a script that anticipates command line output by automatically interacting with the shell based on expect logic. So here's an example of what expect logic is. I expect the shell to read login blah. When it does, automatically type the username. Next, I will expect to read password colon blah. When it does, automatically type the password. So that's what expect logic is. Expect something to happen, and then when it does, do something. And you'll see TCL is probably the most common language used for expect scripting. So what does TCL look like?
It's pretty.
Here's an example of TCL. TCL is a very elegant, pretty language in my opinion. But you see we have the bracket syntax that does the evaluations, just like when we do Objective-C in the Apple development. It's a very common thing in that environment as well. So this is just a very simple program that just allows you to type your first name, type your last name, and then it will just say, hello, whatever. Your first name has this many characters, your last name has this many characters. So very simple, very nice.
HTML, the hypertext markup language, if you're fancy.
Yeah.
It is the universal standard markup language for web pages. It came out in 1991, if you can believe it. 1991.
So you had Nirvana came out with Nevermind, the Black Album from Metallica came out, Guns N' Roses, the Use Your Illusion albums. That was a big year.
HTML.
And HTML kind of rounded it out.
Yeah. And only, 10 years later, 15 years later, we get Chrome, the most perfect representation of HTML. So the source code builds page elements by using tags to represent their instantiation. Page elements can have properties for additional customizations like ID tags or classes or style tags or what have you. Many other technologies integrate with HTML to make, a more advanced website. We have CSS, as I referred to, JavaScript to let you mess around on the page, Flash, which, Flash. And then there's ActiveX.
Yeah, which is pretty much deprecated, but, whatever.
Hey,
You
We
still
gotta
see
mention
it
it
from time to time.
From time to time. Along with C, C++, and Java, HTML is a required language for aspiring developers. You
No
have
doubt.
to learn it.
No
I mean, it's you'd be doing yourself a disservice by not. How are you going to promote yourself without knowing how to build your own web page? It is used so often that it's impossible not to come across it at some point. Even if you're not going to build web pages for yourself or for anybody else, you'll come across a situation where HTML is going to pop up. It's just going to happen. Other technologies leverage HTML, the syntax and how it's built, XML, MXML. It's not
many
really.
others.
There's so many.
Yeah.
Oh, so many. It's not really a programming language. More of a formatting or arranging elements on a page. It's more of a design kind of language. It's implemented in so many ways that I don't even know. Like, it hurts me to think about that. I'm getting brain freeze. So this is what HTML looks like. On your left is what the code looks like. On your right is what it looks like in your web page. If you're on Wibbit.net, there's HTML to display the page. So you've seen the result of HTML code by just being here.
Yeah, that's true.
As you can see, the different H numbers mean something. The one criticism I will always give HTML is that some of its formatting tags aren't exactly, it's not as intuitive as it could be, I guess. But what are you going to do? They came out with it in 1991, right? I mean,
yeah.
What are you going to do?
So let's talk about PHP, the PHP Hypertext Preprocessor. Probably one of the most famous recursive abbreviations ever. Acronym.
Acronym, yep. That's the word you're looking for.
Yeah. General purpose server-side scripting language, and it came out around the mid-90s, and it sort of was based on Perl, and as a matter of fact, the earlier PHP implementations was Perl. So that's kind of a fun little piece of history. It's used pretty much exclusively for web development. Now, I have seen it used, and I myself have used it as a regular scripting language because a lot of its integration with databases is so seamless. It kind of makes it so easy to use that you can use it in the same way that you can use Perl, so why not if you have the opportunity? And it's just regular command line interpreter. And the P in the LAMP stack is actually PHP, the Linux Apache MySQL PHP setup, which is when we get into web architecture and architecting web servers and developing web applications, a little bit down the road, we'll have a more thorough discussion about the LAMP stack, but it just combines your operating system, your web server, your database, and your dynamic programming language. PHP was basically what made Web 2.0 possible. And I'm sure you guys remember there was that era back in the late 90s, early 2000s where, that was when the .com bubble kind of bursted, but the .com bubble bursted because of technologies like PHP was creating so much content. People were able to do so many amazing things on websites that they were not possibly able to do before, and it kind of led to an explosion, really. Now, the reverberations of that explosion still kind of exist today, but the reason why we were able to get over that hump from static web pages was really because of technologies like PHP and CGI. PHP is embedded into HTML content, which makes it separate from its cousin CGI. CGI is basically a Perl script that generates a web page, whereas in PHP, I can actually have hypertext markup and then define tags to implement PHP logic. The acronym for PHP is a recursive acronym. It is personal homepage, which was the original acronym. Personal homepage is what it used to mean, but then the developers were like, that's kind of stupid, so let's just call it the PHP Hypertext Preprocessor. So it's, yeah.
That's a good acronym.
Well, there's a funny story about that, and I don't know how true it is, but PHP came out, and they were asked, what does PHP stand for? And they didn't know, because they were just like, we didn't really think about it. Some people thought that it meant the Perl Hypertext Preprocessor, so they just kind of made a joke out of it and said, yeah, we'll just call it the PHP Hypertext Preprocessor, just to kind of with everybody.
I will say PHP as a file extension and as a grouping of 3 letters, it's pleasing to look at, sort of. It's like it's symmetrical. It's, it doesn't have to mean anything. Things always have to mean something. It's just poop.
PHP and TXT, those are probably the 2 best extensions ever.
They're gorgeous. I think PHP looks a little better. It's a little more pleasing. I like P's. They're a little more soft compared to the hard edges of a T.
Yeah, no, I got you. And there's the X is a bit abrasive, so I understand.
Yeah, I'll take PHP over TXT any day.
PHP shares a lot of similarities with Perl. Original PHP development began as actually just a series of Perl scripts. Code injection is accomplished by opening and closing PHP tags within a PHP script. Kind of alluded to that a second ago, but there is an open PHP tag and a closed PHP tag, and then all the code in between those is the PHP logic. And the PHP interpreter will actually execute that as a script, and then whatever the output is, it will just stick it in that location. It incorporates many advanced programming structures, which includes object-oriented programming. PHP code is often interpreted, so you'll have a PHP interpreter on a web server that runs it, but there are some developers out there that kind of get crazy and say, well, that's too slow. They'll actually compile their PHP into native machine code. You can actually do that, and some developers prefer to do that. In most common implementations of PHP, a web server is often required, such as Apache or IIS or something along those lines. Nginx, whatever. Your own HTTP server, because you can write those if you follow the C# course. You don't need to have Apache or that. You could run it as a command line interpreter, but most of the time you'll see it executed by a web server. So let's take a look at what PHP looks like. Now, you'll probably look at this right now and say, this is not PHP, this is HTML.
You have gone crazy.
Yes. So basically what we're showing here is the source code that was produced by a PHP script. So when you look at code that is produced by PHP, you will not see the PHP code in there. You'll just see the result of the PHP
Wait a minute,
code.
Kevin. In your URL there, I noticed a few arguments.
There are some arguments. And I also see that there is a syntax error. I don't actually close the HTML tag in this. But let's pretend like that's not there, and I'll just put a little scratch there.
Just don't worry about that little guy.
Yeah. Well, this is not an HTML class anyway. We'll do that later.
Yeah.
So the code on the right is produced from the code on the left. So at the top of the PHP script, there is a open and closed PHP tag with some PHP logic in it. So we have a variable called page body, and by default, it's set to body is not set. I just have some logic to check to see if there is a query string get parameter called body, which if you look at the top of the location bar there, you'll see that there is a body equals hey buddy. Set the page body equal to hey buddy, and then the title, which will be coming from the query string, and the page body will be echoed out using PHP. So you can see how we can just kind of inject this logic into a web page, and the outcome of that will be just HTML, at least in this case.
JavaScript.
Java!
Well, now we've talked about how we can interact with the server-side language with HTML. Now let's talk about doing some more interesting things on the client side. JavaScript is a dynamic and weakly typed scripting language originally developed for web page integration in 1995. Ooh. And as some would tell you, JavaScript has literally changed the world.
Absolutely.
The sky was purple.
Yeah.
Before 1995. Nobody remembers that, but it was. JavaScript changed the planet.
It certainly did.
I made that up. That was not real. Don't tell people that I said that. Syntax is similar to C++, and some call it C++ for the web. I've actually never heard anybody say that, but we can go with that. JavaScript in web pages is interpreted and executed by a JavaScript engine in the browser itself. Mm-hmm. I don't know if anybody of you out there have noticed, but sometimes you'll notice a different interaction on a website based on what browser you're using. Mm-hmm. That sometimes has something to do with the way the JavaScript is being interpreted by the browser's JavaScript engine. Mm-hmm. Technologies built on JavaScript are many. Ajax. Some would argue Ajax is more of a philosophy or a method of coding than it is an actual technology in and of itself, but it's asynchronous. Ajax stands for asynchronous JavaScript and XML, and that allows web pages to interact with the web servers. So JavaScript lets you send a request back to a backend server like a PHP server to get a response back to allow your page to change and flow with you as you're using it. That's what Ajax is doing, and JavaScript makes that possible because JavaScript is able to see what you're doing. JSON stands for JavaScript Object Notation. It's a text-based standard of storing human-readable data, and it has a very similar function to XML in that it's a way to kind of package up data and send it back and forth. Also, we have jQuery, which is a JavaScript library intended. The reason for jQuery is to make JavaScript a little bit easier. It's to make it easier for you to write JavaScript scripts, and it provides an infrastructure for interacting with HTML objects, CSS events, animations, AJAX, etc. In fact, we've talked about AJAX, we've talked about JSON. With jQuery, you can perform AJAX interactions or make calls to the backend web server with PHP very easily, very simply through simple script lines. And you can actually pass JSON instead of XML. You don't have to pass XML. jQuery makes everything very easy for you.
Yeah, and see, I don't know if I would agree that AJAX is a philosophy because the asynchronous portion of it still had to be introduced. Now, the philosophy is the XML part because that is arbitrary. It was originally used for like doing like SOAP posts and that kind of stuff where like XML was the data type, but
Right.
we've evolved beyond that, but the acronym still remains the same.
Well, there's other acronyms like AHA and stuff like that. And purists, there are people out there that'll sit there and argue with you about, which is the correct acronym. Is it a technology per se? Is it its own language? Or is it, just a method of accomplishing
Yeah, I mean,
something?
it's certainly just the technology that's built on JavaScript. Asynchronous JavaScript, I think, is the best way to describe it.
Absolutely. I mean, the XML, JSON, however you're passing things back and forth, JavaScript has made it possible for us to have an interaction on a page and then have something interact with data on another computer somewhere else and then come right back to your page without any refreshes or any kind of event that you notice yourself. So what does JavaScript look like? JavaScript looks ugly. It looks ugly. Horribly ugly. But this is pretty much it. Just like PHP, you can embed it in your HTML script, and it doesn't have to. It can be on its own. In fact, it's oftentimes on its own in its own JS file, but it can be put right there in the HTML as it is in this example. Here we have a button that click me. When you click me, it'll run the JavaScript that's further up on the page. Unlike PHP, where it's kind of interpreted and injected into the code right there, JavaScript can be written and then some other event or some other happening can make that script or logic actually fire and run.
Right, so by clicking on it, we get this little alert box that says, "Thanks for clicking!"
Oh, you're welcome.
At least it was polite.
It's very polite.
Shebang! I have a little funny story about like a job I used to have where there was some issue where the script wasn't running, and somebody said, "Did you bang the script?" And I thought that was kind of funny. And they were referring to this notation here. Shebang is a character sequence that begins with a hash and a bang, or a she-bang, because whatever.
Yeah.
And oftentimes in like Linux or Unix, you'll put this at the beginning of a script and it will tell the command terminal what interpreter to run this with. So oftentimes if you're running a Perl script, you'll type Perl and then the script. But if you want the script to be able to just run on its own, sort of, you tell the shell, hey, if someone just runs this from the command line, just run it against this interpreter. So you can specify things like bin sh to run a shell script, csh for a corn shell script, user bin Perl, user bin Python, whatever, wherever those locations are. But we just wanted to introduce this to you because if you do any work in the Unix environment or Linux environment, I think pretty much more often than not, your interpreted scripts will be headed with a shebang. So that's so that you know what that is. Some controversy. Ooh. Jason, is SQL or SQL a scripting language?
If you want to get technical, yes, it is.
But people fight about this all the time, but I'm sorry, man. SQL is a scripting language.
I mean, the Oracle has definitely taken steps with PL SQL to make it a little more dynamic and everything, but but that's no different than any of these other languages we've talked about. The line gets blurred in every direction. SQL is absolutely a scripting language. It is run as it's interpreted as it goes. It's written in order. It fits the criteria.
Mm-hmm.
In every way, shape, and form, it is a scripting language.
Yes. So that is the end of the introduction to scripting languages. We did a really fast sprint around the track on this one.
Well, I am exhausted, so sudo make me a sandwich.
Crash.